Hello everyone, this is Mr. Gibson and I am recording this video with a few select problems from your exam 3 review. We're going to start with number 12. It says use intersect on a graphing calculator to find the solutions to 1/2 x squared plus 2x minus 1/2 equals x plus 1. So the first thing we want to do is press the y equal key on your calculator. So now once you press the y equal key, you're going to put a value in y1 and you're going to put a value into y2 as well. Now under y1, since we know 1/2 is really 0.5, we could type in 0.5 x squared plus 2x minus 0.5. And then next, we would type in, with y2, we would type in x plus 1. Now, let me explain something here. With your x value, some people do not know where the x key is on the calculator. Your x key is right next to that lime green alpha key. It is the key right next to the lime green alpha key. So you would type in 0.5, hit the x key, and then hit the x squared key, plus 2x minus 0.5, and then enter, and then type in x plus 1. Now you're going to press graph. Now, your graph is going to look somewhat like this here. Let me see. Okay, it's going to look somewhat like this here. Okay, now we have your graph. Now what we want to do in our calculator next, after you have your graph, press second and then press the trace key. The trace key is right next to your graph key. So again, you would press second, then trace, and then you see the number 5 that says intersect. Press the number 5. Now when you press the number 5, you're going to have to press enter 3 times after that. Now, when you do this, we are basically looking for the x value. So if you look here, our x value is 1. Now, most of your calculators, you will start off with your x value being 1. So that's one of your answers. Now, to find the other answer, because you see that this line intersects 2 places on this parabola, what you need to do is this here. Right now, your intersection is here. Right now, your intersection is here. But we need to get our intersection to go over here. So what we would do is, after we got our first x value, we'll press second and trace again, then the number 5. Now, before we press the enter 3 times, we need to press the right arrow until we get to where the graph intersects again. Now let's go back through that again. You were supposed to press second and trace. And then you're supposed to press the right arrow until you get where the graph intersects again. And then you will press enter 3 times. And that will give you your other x value, which would be -3. Now, this is the answer here. X is 1 and also x is -3. Now, let me just state this here. You may have a calculator where when we first started off, it gave you x equals -3. If it gave you that, you would just have to reverse the directions I told you. You would get your x is -3. Then you would press second and trace, but instead of and then the number 5. And then instead of pressing the left arrow key, you will press the right arrow key until you get to this intersection here. And then you will press enter 3 times. Okay, now we need to scroll down here to problem 13. Okay, now with problem 13, we're basically dealing with two different formulas here. The first formula we're going to write here is f of x is equal to, we had x minus, well, a times the parenthesis x minus h parenthesis squared plus k. Now, what happens here when you have this type of formula and then subtraction on the inside of the parenthesis, your h is your x value, and whatever your k is your y value, and that will be your vertex. Now we know A determines if your graph goes up or down. If A is negative, it goes down. If A is positive, it goes up. Okay, now there's another formula we're basically going to use here, which is f of x is equal to ax squared plus or minus k. Now, what happens here is a still represents the same thing, but k here represents whether the graph goes up or down. If k is positive, the graph will shift up. And then if k is negative, the graph will shift down. Now this is a little different than what I said with A. A just basically tells if your parabola opens up like this or opens up like this. That's what's meant by up or down. But here with K, it'll actually shift it up or down. Like for instance, I'll put a little representation here. Say the graph was like this here originally. But then say you got the same x squared value, but let's just say you have x squared plus 2. Then it would shift the graph up 2. See, this is the difference between whether it's opening up or opening down. Now, this was shifted up if k is positive. It was shifted down if k is negative. So if we took this same graph and say k was negative 2, then this same graph will go down 2. So that's what's meant by shifting up or down. Now there is another formula that I forgot to include, but it's very necessary. If we have f of x is equal to x minus h squared. Now what this determines is the direction that the graph moves in. Like this determines if the graph shifted up or shifted down. H here determines if the graph shifts to the right or shifts to the left. Now, if you have it where it's subtraction inside of your parenthesis, subtracting h here, then it'll shift to the right. But then if this ends up becoming plus h, it'll shift to the left. Now let's go through that again. If the equation is written like this here where h is subtracted, then it'll shift to the right. If it's written with addition of h like x plus h, then it'll shift to the left. Now let's take a look here. Let's apply this. Now finding the vertex here is quite easy because it's in this form here. The vertex here would be positive 12, because that's our h, and then negative 8. That is our k. Now, we go down here to g of x. Let's just do the same thing here. Now, if you notice here, we have an h, but we don't have a k. When we have an h but no k, we know that k is 0. So here, since this is a plus 1 instead of minus, it'll be negative 1 for h and 0 for y. Now we come here. We have 6x squared plus 18. Now we want to find the vertex. Now we do not have an h here. So our h here would be 0. But we do have a k, which is 18. Now we come here. It's the same basically as this first equation here. Our h is negative 5. and our k is a negative 12.5. So now we took care of all of the vertexes. Now for the open up or down, we just look for the a values. Now remember, our a value is typically in front of the parenthesis that's squared, or the number in front of the variable squared. So here we know this is negative, so it's down. We know it's negative here, it's down. We know it's positive here, it's up. And then here we know this a is positive 1, so it also opens up. Now we have to go shift it up or down. Now remember, our k determines if it shifts up or down. So basically we could look here at our y values. This y value is negative, so it's down. This y value is 0, so it's none. This y value is positive 18, so it's up. This y value is negative, so it's down. Now we go here, shift it left or right. We could look here at our x values from our vertex, because this is our h values. We know if our vertex is positive, it goes to the right, because that means it was negative inside the parenthesis. Now if it's negative, we know it goes to the left. 0, that means none. And then again, if it's negative, we know that it goes to the left. So that took care of this table. Now we come down here to F, G, and H. Now we're asked, which is the narrowest graph? Okay, now, as far as finding the narrowest graph, it's basically based on A. If A, whatever A here is the largest A is the narrowest graph, and whatever A is the smallest is the widest graph. So this is what we would do. Let's look here at our A's. This is negative, but we have a positive A here, and we know that this positive 1 is also positive. So we know that these two here would not work because they're smaller than any positive number. We know that this a and k of x is positive 1, but in h of x, a is positive 6, and 6 is larger, so then that would be the narrowest graph. So it'll be h of x. Now the widest graph is our lowest number. Now we know our lowest number is going to be one of these negatives here. Now remember, when we're dealing with a negative, it's the number that's furthest away from 0. And we know negative 1.5 is further away from 0 than negative 4/5. So we know that our widest graph will be f of x. Now it says which graphs have two x-intercepts. Now we're going to go through each one of these. Now, if we add 8 on both sides, now imagine this, we're going to make this 0. Now we're going to have to do a lot of mental math here. So let's first start this off. We know we would add 8 on both sides. So we would have 8 is equal to negative 1.5 and then the parenthesis x minus 12 squared. Now let me tell you this. Before we take the square root of both sides, if this answer is positive over here, when we're about to take the square root, then we will have two answers. If it's not, if it's 0 or negative, then we don't have two answers. So if we divide each side by negative 1.5, we know that this is going to be negative. So it'd be 8 over negative 1.5 is equal to the parenthesis x minus 12 squared. Now we would take the square root of both sides, and we know this is negative, so we know that this first one doesn't work. Now, on this side here, we will add 0 is equal to a negative 4/5 times x plus 1 parenthesis squared. Now, we'll multiply each side by this negative, well, we could divide each side by a negative 4/5. And we know this is still 0, and this would be x plus 1 parenthesis squared. Take the square root of both sides. We know that this doesn't work because this is 0. Now we come here. We know when we subtract 18 and divide by 6 on both sides, this is also going to be a negative. The only one that works is the k of x. Because when we add 12.5 on both sides, we'll take the square root after that, and this is a positive. So we know